Good morning, students. Now we discuss about the example 7.57 chapter 7 continuation part. Now you see the question. Determine the intervals of concavity of the curve f of x equal to x minus 1 whole cube into x minus 5, x belongs to R, and the points of inflection if any. So they ask about the intervals of concavity and they ask about the point of inflection. So first, this is given functions f of x equal to x minus 1 whole cube into x minus 5. This is a given functions. Now that means I expand the x minus 1 whole cube, a minus b whole cube. That means a cube minus 3a square b plus 3ab square plus b cube. So here that means the formula is a cube minus 3a square b plus 3ab square minus b cube. This is the formula for x minus 1 whole cube formula. So now that means I expand this. X minus 1 whole cube means first a cube means x is cube. Here x is cube only will come, 3 not come. Minus 3a square, here minus will come, minus 3a square is a x square minus 3x square plus 3a b square is 1, so 1 square is 1, so plus 3ab means 3x minus b cube means here b is a 1, so b cube means minus 1 into x minus 5. So the next step, now we multiplied the this is here x cube minus 3x square plus 3x minus 1 into x minus 5. So the next step, now we multiply the x with the x with this factor, so x into x cube x power 4 minus, here minus will come, minus 3x square into x minus 3x cube plus 3x into x plus 3x square minus 6. Next I multiply minus 5 with this factor, so minus 5 into x cube minus 5x cube minus into minus plus 5 3s are 15x square minus 15x plus 5 minus into minus plus 5. So the next step, x power 4 minus 3x cube minus 5x cube minus 8x cube, 3x square plus 15x square plus 18x square. Next minus x into minus 15x minus into minus, here minus will come, minus 16x. Next step plus 5. The next step, now I take the first derivative, so differentiate with respect to x. So f dash of x equal to, first I differentiate the x power 4. Differentiation of x power 4 is 4x cube minus, I write it minus, next 8 into differentiate the x cube. Differentiation of x cube is 3x square, so 8 3s are 24. Next minus will come, minus 24x square. Next plus 18 into differentiate the x square is 2x, so plus 13 plus 36x. Next minus 16, here minus will come, minus 16x, so minus 16, so here minus 16 will come. Therefore f dash of x equal to x, that means f dash of x equal to 4x cube minus 24x square plus 36x minus 16. This is the f dash of x. Next f double dash of x equal to, that means here again I differentiate the first derivative, so from this I get the second derivative. So now I differentiate the first derivative, therefore differentiate with respect to x. F double dash of x equal to, now I differentiate the x cube. Differentiation of x cube is 3x square, so 4 3s are 12x square. Next here minus 24, minus will come, so minus 24 into differentiation of x square is 2x, so minus 48x plus differentiation of 36x is plus 36. Differentiation of x is 1, so f double dash of x equal to 12x square minus 48x plus 36. This is the second derivative. So first derivative, second derivative. Now they ask about the intervals of concavity. So intervals of concavity means the condition is f double dash of x equal to 0. So here they ask about the intervals of concavity, so I take the condition f double dash of x equal to 0. So this is f double dash of x equations, that means 12x square minus 48x plus 36, so equal to 0. The next step, you see 12, 48, 36, everything is a multiples of 3, so thoroughly I divide by 3, so 4, that means 4 3s are 12, so 4x square again minus, that means 1 3s are 1, 6 3s are 18, so minus 16x, 1 3s are 3, 2 3s are 6 plus 12 equal to 0. In the next step, 4x square minus 4x minus 12 minus, that means 4x square, here minus 4x square minus 16x plus 12 equal to 0. Now I factorize this, so that means I write it 4 into 12 48. So we take the two numbers, that numbers gives the multiplication of the two numbers gives 48, and I add the two numbers give the minus 16. So I take the minus 4 minus 12. So multiply the minus 4 and the minus 12, which gives the 48, and adding these two numbers, which gives the minus 16. Therefore I write it 4x square minus 4x minus 12x plus 12 equal to 0. So the next step, now I write the, you see the first two term 4x is common, so I take the 4x from the first two terms. So 4x into the remaining terms I write, that means 4x square, I take the 4x from this term. So remaining terms x minus 4x I taken from the outside, so remaining term minus 1. Therefore 4x into x minus 1. The next last two terms I take the minus 12, so minus 12. So I take the minus 12 from the third term, so remaining term is x. Remaining next fourth term I take the minus 12, but there is no 12 is occurred, so I take but I take the minus sign from the plus, so there is no minus sign, so I change, that means I write it minus, because minus into minus again I get the plus 12. So just again you multiply the minus 12 into this factor, you get the previous step, that means minus 12 into x minus 12x, minus into minus plus 12, so equal to 0. In the next step, you see here the inside of the bracket x minus 1, x minus 1, it is a common factor, so I take outside, so x minus 1 into 4x minus 12. Therefore 4x minus 12 into x minus 1 equal to 0. This is your term. Next 4x minus 12 equal to 0 means now I take the, so there is a two factor, one is 4x minus 12 equal to 0, another one is x minus 1. So each factor I taken to 0, so 4x minus 12 equal to 0, x minus 1 equal to 0. So 4x equal to 12, so I take x equal to, that means 12 by 4 3. Next x equal to 1. This is a x values. Now I substitute in the number line, so minus infinity plus infinity 1 3. So the interval is minus infinity to 1 1 2 3 3 to infinity. Therefore intervals, I take the three columns, one is intervals and another one is sign of, here I take f double dash. They ask about the concavity, so they ask about the concavity means you just take the f double dash, no f dash. Okay, monotonicity only. Suppose they ask about the monotonicity means at that time you take the, that problem you take the f dash, but in this problem they ask about the concavity, so concavity means you take about the f double dash, so sign of f double dash. And next monotonicity, now again minus infinity comma 1, so 1 comma 3 3 comma infinity. So now minus infinity comma 1 means you take suppose you take any numbers and substitute in the f double dash. Suppose I take the x equal to 0, so I substitute x equal to 0 in the f double dash. I get the answer f double dash of 0 equal to 36. 36 is come in the plus sign, so plus, I represent the sign is plus, therefore plus represent the concave upward. Next 1 comma 3, so 1 comma 3 means you take the 1 comma 3 means you take any numbers x equal to 2, so x equal to 2 means f double dash of 2, f double dash of 2 equal to, you substitute in the f double dash, that means f double dash of 2 equal to, you substitute, so your answer is minus 12. So minus sign represent minus, concave downward, so this is a concave downward. Next 3 comma infinity, so 3 comma infinity means you write, that means 3 comma infinity, I write it here. So therefore, so here now I write it the, that means 3 and infinity, between the numbers you take and substitute in the f double dash. Now I take the x equal to 4 and substitute in the f double dash, so x equal to 4 I substitute in the f double dash means I got the answer 36. So the sign is plus, therefore concave upward, therefore the curve is concave upward on minus infinity comma 1 3 comma infinity, and concave downward on 1 comma 3. Therefore f double dash changes is a sign which passes through x equal to 1 and x equal to 3. Therefore here you see, that means f double dash changes is sign which passes through x equal to 1 and x equal to, you see plus into minus, plus minus, sign changes, minus plus, sign changes. So plus minus at the point x equal to 1, minus plus at the point x equal to 3. So here sign changes. So therefore now when x equal to 1, so x equal to 1 means just substitute here f of 1. That means we know that f of x equal to, that means we know the functions f of x equal to x minus 1 whole cube x minus 5. So I substitute here x equal to, that means So first point is x equal to 1 and x equal to 3. Here they take the x equal to 3. So we substitute the x equal to 3. So therefore f of 3 equal to 3 minus 1 whole cube 3 minus 5. Therefore 3 minus 1 whole cube is 2 cube. 3 minus 5 is minus 2. So 2 cube is 8. 8 into minus 2 minus 16. F of 3 equal to minus 16. The point of inflection are 1 comma. So the point is 3 comma minus 16, and next the pointer is, suppose you substitute x equal to 1, you get the answer 0. F of 1 equal to 0. Therefore the point of inflection are 1 comma 0 3 comma minus 16. Therefore the point is, here you take the x equal to 3, not x equal to 1. So we find out the from this problem we found the intervals of concavity and the inflection point. So next example 7.58, determine the intervals of concavity of the curve y equal to 3 plus sin x. So you see the example 7.58. So determine the intervals of concavity of the curve y equal to 3 plus sin x. The given function is a periodic function, you see the given function is a periodic function, that means with a period 2 pi. So now you write it, y equal to, you write the given functions. In this questions they ask about the intervals of concavity. So first I write the given functions, y equal to 3 plus sin x, dy by dx equal to, definition of 3 is 0, definition of sin x is cos x. Next d square y by dx square equal to, definition of cos x is minus sin x. Therefore d square y by dx square equal to 0, so minus sin x equal to 0. So minus sin x equal to 0 means a sin, that means you write it, that means sin n pi equal to 0. So both the side I substitute sin n pi, that means sin x equal to minus sin x, I taken the sin x equal to 0 and the sin x equal to sin n pi, sin cancelled, x equal to n pi. And next now, so and x, that means x equal to n pi. So now I consider the x equal to 0. So x equal to 0 means this is a general value, so sin x equal to, that means sin 0 is also 0, so sin cancelled, x equal to 0 and the general value is x equal to n pi. So I substitute here x equal to 0 in the middle. So minus pi to plus pi, here 0 is substitute in the middle, not 3, here 0 will come. So now consider an interval minus pi comma plus pi and 0 in the middle. So the intervals are minus pi comma 0, 0 comma pi. Therefore now I take the intervals minus pi comma 0, 0 comma pi. Therefore interval, now I make it the tables, intervals column, sign of f double dash of x and monotonicity. Now interval is minus pi comma 0, 0 comma pi. Therefore now I substitute any numbers from this interval. I got the plus sign in the answer. Therefore it is a plus sign, means I represent a concave upward, and a 0 comma pi I take the, that means 0 comma pi means you substitute suppose x equal to 30 degree, x equal to 45 degree in the f double dash of x. I got the minus sign in the answer, so concave downward. Therefore the curve is concave upward on minus pi comma 0, the curve is concave downward on 0 comma pi. So therefore the curve is concave upward on minus pi comma 0, the curve is concave downward on 0 comma pi. From the table I tell it. So therefore d square y by dx square changes its sign when it passes through x equal to 0. So now you see the tables, that means plus minus sign changes. So d square y by dx square change its sign when it passes through x equal to 0. Therefore when x equal to 0 I substitute in the function y equal to 3 plus sin 0. So sin 0 is 0, y equal to 3. Therefore the point of inflection is 0 comma 3. So the general intervals are, so general intervals we know n pi, that means n pi comma n plus 1 pi. So x equal to n pi. So substitute x equal to n pi, I got the answer y equal to, that means here in the given function I substitute x equal to n pi. So y equal to 3 into 3 plus sin n pi. Sin n pi is 0, so y equal to 3. Therefore the point of inflection are n pi comma 3. This is the point of inflection. Next example 7.59, find the local extreme of the function f of x equal to x power 4 plus 32x. Now you see they ask about the local extreme. So local extreme means here we find out the local extreme, we take the f dash of x. Concavity, intervals of concavity means we take the f double dash of x equal to 0. Local extreme we take the f dash of x equal to 0. So first I write the given function f of x equal to x power 4 plus 32x. Next now I take the first derivative, differentiate with respect to x. So f dash of x equal to 4x cube plus 32, because the differentiation of x power 4 is 4x cube and the differentiation of 32x is 32 into differentiation of x is 1. So f dash of x equal to 0. So now I take the f dash of x equal to 0. So 4x cube plus 32 equal to 0. So 4x cube equal to this plus 32 I write in the minus 32. So x cube equal to minus 32 by 4. So now minus 32 by 4 means that means I cancelled the 4 and the minus 32. So minus 8. That minus 8 I write it minus 2 whole cube. So minus 2 whole cube means x equal to minus 2. Therefore the x value is minus 2. Therefore the critical point is x equal to minus 2. So f double dash of x equal to, now next I calculate the f double dash of x. F double dash of x equal to 12x square. So the next step, at x equal to minus 2. So I substitute. So because already I found the x value is minus 2, so at x equal to minus 2, f double dash of x equal to, here minus 2 I substituted in the f double dash. So minus 2 whole square 4. So 12 into 4 48. So f double dash of minus 2 equal to 48. I got the, that means a positive sign in the answer, therefore greater than 0. Therefore f double dash of x greater than 0. Therefore f dash of x has local minimum. Greater than 0, so it represented the local minimum. Suppose less than 0, it represented the that means local maximum. Therefore f of x, small f of x has local minimum at x equal to minus 2, and the local minimum value is, so the local minimum value is, that means f of minus 2 equal to, that means we substitute f of minus 2. So minus 2 means minus 2 whole power 4 plus 32 into minus 2. Therefore minus 2 whole power 4 is 16, minus 32 into minus 2 minus 64. So minus 48. Therefore f of minus 2 equal to minus 48. This is the local minimum value at the point x equal to minus 2. So local minimum equal to minus 48. Therefore the extreme point, so the extreme point is minus 2 comma minus 48. This is our extreme point. So next is 7.60, find the local extreme of the function f of x equal to 4x power 6 minus 6x power 4. You see, so this is now we discuss about the example 7.60. So find the local extreme of the function f of x equal to 4x power 6 minus 6x power 4. So f of x equal to 4x power 6 minus 6x power 4. So if I take the differentiate with respect to x. So f dash of x equal to 4 into, I differentiate the x power 6, differentiation of x power 6x power 5. So 6x power 5 means 4 6 are 24, 24x power 5 minus 6 into differentiation of x power 4 is 3x cube. So that means not 3, 4x cube. So 6 4s are 24, 24x cube. So next step, f dash of, they ask about the local extrema. So now we find out the point x value. So from the f dash of x equal to 0, so I take f dash of x equal to 0. So f dash of x is 24x power 5 minus 24x cube equal to 0. I take the 24x cube from the point, so remaining term is x square minus 24x cube I take from the second term, so minus 1 equal to 0. So therefore 24x cube equal to 0, x square minus 1 equal to 0. Therefore x cube equal to 0 and x square equal to 1. Therefore x equal to 0 thrice, because its degree is 3, so thrice, that means x equal to 0 comma 0 comma 0, it is a thrice. And next x equal to, now I take the square in the right hand side, square root. So square root of 1 is plus or minus 1, therefore x equal to plus or minus 1. Therefore the critical points are, now I find out the critical point, that means 0 plus 1 minus 1. So I substitute minus 1 comma 0 comma 1. This is the critical points. Therefore critical points are minus 1, 0 and plus 1. Now f dash of x. So f dash of x means, now I take the, that means I differentiate. Already I got already I got the f dash of x. F dash of x equal to 24x power 5 minus 24x cube. Now I calculate the f double dash. This is f double dash. F double dash means now I take the differentiation in the, that means the x power 5. Differentiation of x power 5 is 5 into x power 4. So 24 into 5 is 120. 120 x power 4 minus 24 into 3 into x square. So 24 into 3 is 72 minus 72 x square. Therefore 120 x power 4 minus 72 x square. This is the f double dash of x. So next 120 x power 4 minus 72 x square. So x equal to minus 1. Now I substitute the first point, x equal to minus 1. So x equal to minus 1 means, so f double dash of minus 1 is 48. The answer is f double dash of minus 1, answer is 48. So there is a plus symbol in the sign in the answer, so greater than 0. Therefore f of x as local. Greater than 0 means we take x equal to minus 1 is the low, f of x is the local minimum at the point x equal to minus 1. That means that x equal to 1. So f double dash of x greater than 0. So I substitute x equal to 1 in the f double dash. F double dash of 1 equal to, it is a positive answer. So I represented the f double dash of x greater than 0. So next, so greater than 0 means I tell it is f of x as local minimum at x equal to 1. So next, x equal to 0. I substitute x equal to 0 in the f double dash of x equal to 0. So it is equal to 0 means we not represented by, it is local minimum, local maximum. So we can't, that means we can't find out the local minimum and extremum. So therefore in the next step, now I take the number line, that means minus infinity to plus infinity. I mark all the x values, minus 1, 0, 1. Therefore the intervals are minus infinity comma minus 1, minus 1 comma 0, 0 comma 1 and 1 comma infinity. These are the intervals for the our given problem. So the next step of intervals. Now I take the tables, intervals, and next sign of f dash of x, next monotonicity, because they here in this problem they ask about the local extremum. So local extremum means it is a increasing and decreasing. So when we tell about the increasing and decreasing means we take the f dash. Suppose they ask about the concavity means we take the f double dash. So in this table we tell about only increasing and decreasing functions, so I consider f dash of x. So therefore now that means I make it the tables. First column represented by interval, second column represented by sign of f dash of x, third column I represented by monotonicity. So now that means I enter all the intervals, minus infinity comma minus 1, minus 1 comma 0, 0 comma 1 and 1 comma infinity. So I substitute any values from this interval. I got the answer, I got the symbol minus sign in the answer. So I tell it is a strictly decreasing. Minus sign means it is a strictly decreasing. The next, that means I substitute the values from this interval. I got the sign plus in the answer. So here I represented the plus. Plus means strictly increasing. Next, 0 comma 1. 0 comma 1 means I substitute any values from this interval. I substitute in the f dash of x. I got the answer. I got the sign in the answer minus. So strictly decreasing. Next, 1 comma infinity. 1 comma infinity means I substitute any values. Suppose I take x equal to 2. I substitute in the f dash of x. I got the plus sign in the answer. So strictly increasing. Therefore minus strictly decreasing, plus strictly increasing, and the minus strictly decreasing and the plus strictly increasing. Therefore f of x is strictly increasing on, from this table I conclude that f of x is strictly increasing on minus 1 comma 0 and 1 comma infinity, and strictly decreasing on minus infinity comma minus 1 and 0 comma 1. Therefore f dash of x changes from negative to, you see the tables here, the sign changes from minus to plus, plus to minus, minus to plus. So minus to plus, it is a local minimum, plus to minus local maximum, minus to plus local minimum. So now f dash of x changes from negative to positive when passing through x equal to minus 1 and x equal to 1. So f of x is local minimum at x equal to minus 1 and the local minimum value is, so that means f of x is the local minimum at the 2 point. The first point is, so f of x is a 2, that means x equal to minus 1 and x equal to 1. At the 2 point it has the local minimum. So therefore f of s is local minimum at x equal to minus 1. Therefore local minimum value is I substitute in the function f of minus 1 equal to, that means I substitute f of, that means I write it f of x equal to 4x power 6 minus 6x power 4. So x value is minus 1 whole power 6 minus 6 into minus 1 whole power 4. Therefore 4 minus 6, so minus 2. This is the local minimum value. This is minus 2 is the local minimum value. Therefore f dash of x's sign changes positive to negative when passing through x equal to 0. Therefore f of s is local maximum. So positive to negative means it has the local maximum. F of x is local maximum at x equal to 0, and the local maximum value is f of 0 equal to 0. Therefore f dash of x changes from negative to positive when passing through x equal to 1. So f of x is the local minimum at x equal to 1. So under the local minimum value is f of 1 equal to 4 into 1 power 6 minus 6 into 1 power 4. So 4 minus 6 minus 2. This is the local minimum value. So minus 2 is the local minimum value, and the local maximum is 0. Because f of 0 equal to 0, it is the local maximum. Next example 7.61. Find the local maximum and the minimum of the function x square y square on the line x plus y equal to 0. So first I write the, that means they ask about the find the local maximum and the local minimum of the function x square y square. So f of x equal to x square y square and x plus y equal to 0. So I write the, this is the function, this is the line. So I write y equal to 10 minus 6. So I substitute this y in the function f of x equal to x square 10 minus 6 whole square. So I write it f of x equal to x square into, I expand this, a minus b whole square, a square minus 2ab plus b square. So a square means 100 square, 10 square is 100 minus 2 into ab. So 2 into 10 into x minus 20x plus b square. Here plus will come, plus b square means plus x square. So f of x equal to, that means x square into 100 minus 20x plus x square. Now I multiply this x square in the factor. So I write it x square into 100 x square into minus 20x cube. Here plus will come, x square into x square x power 4. So x power 4 minus 20x cube plus 100 x square. This is the f of x. Now I take the f dash of x. F dash of x equal to, now I take the differentiation. Differentiation of x power 4 is 4x cube minus 20 into differentiation of x cube is 3x square. So minus 20 into 3 minus 60x square plus 100 into differentiation of x square is 2x. So 100 into 2x is plus 200x. Therefore f dash of x, now I take the f dash of x equal to 0. So f dash of x equal to 0 means now I write it, this is equal to 0. So 4x cube minus 60x square plus 200x equal to 0. So that means now you see the all the terms are, it is multiples of 4. So I thoroughly divided by 4. So I write it x cube minus, I divide the 4, I divide the 6 by 4. So 60 by 4, not 6, 60 by 4 and 200 by 4. So 60 by 4 means it is represent, that means the answer is 15. So x cube minus 15x square plus 50x equal to 0. This is the equation for, we divided the by 4 in this equation. So next you see x is common to in the all the terms. So I take the x from this term. So x into x square minus 15x plus 50 equal to 0. Now there is a two factor. First factor is x, second factor is x square minus 15x plus 50 equal to 0. So each factor I equate to 0. So x equal to 0, x square minus 15x plus 50 equal to 0. So the next step, so x equal to 0, next term x square minus 15x plus 50 equal to 0. Therefore I write it, that means x square minus 15x plus 50 equal to 0. So x square minus 15x plus 50 equal to 0. Now here, now I factorize this equations. So I write it x minus 10, x minus 5 equal to 0. So each factor equal to 0, x minus 10 equal to 0, x minus 5 equal to 0. So x equal to 10, x equal to 5. So therefore the critical points are x equal to 0 and 5 and 10. Now f dash of x, we know the f dash of x, that means 4x cube minus 60x square plus 200x. This is f dash of x. F double dash of x means 12x square, 60 into that means 120. Here 120 will come, minus 120x plus 200. This is the f double dash of x. Now first I substitute the x equal to 0. So x equal to 0 means f double dash of x. So x equal to 0 means f double dash of 0 is answer is 200. So f double dash of 0 equal to 200. So it is a positive. So f double dash of 0 equal to 200. So it is a greater than value, greater than 0. So it is a greater than 0 means I tell about it is a local minimum. So therefore f of x as local minimum at x equal to 0. And next I substitute the local minimum value. Now I find out the local minimum value. So I substitute x equal to 0 in the given function. So f of 0 equal to 0. This is the local minimum value. The next I substitute the second value, x equal to 5. So x equal to 5 means f double dash of x. Now I substitute x in the double dash. So f double dash of 5 equal to 12 into 5 square minus 12 into 5 plus 200. So I got the answer f double dash of 5 equal to minus 100. This is the less than 0. So less than 0 means f of x is the local maximum. So local maximum means I substitute. So I represented here substitute x equal to 5 in the double dash. So f double dash of 5 equal to, I got the answer minus 100. So minus 100 means it is a less than 0. So less than 0 means f of x is local maximum. Less than 0 we tell about it is the local maximum at x equal to 5. And local maximum values, now we find out the local maximum value. So I substitute x equal to 5 in the given function. So therefore f of 5. So f of 5 equal to 5, we substitute 5 in the function. 5 square 10 minus 5 whole square equal to 5 square 25. 10 minus 5, 5 square 25. 25 into 25 625. So this is the f of 5 equal to 625. So this is the local minimum value. So it is the local maximum value. 625 is the local maximum value. I represented here. So next value I substitute x equal to 10. I substitute x equal to 10 in the f double dash of x. So f double dash of x. So I got the answer f double dash of 10 equal to 200. So f double dash of 10 equal to 200 means it is a greater than 0. So greater than 0 means it is a local minimum value. So minimum. So therefore f of x is the local minimum at the point x equal to 10. So I substitute x equal to 10 in the functions. So I substitute here, that means 10 square 10 minus 10. 10 minus 10 is 0. So therefore f of 10 equal to 0. This is the local minimum value. 0 is the local minimum value. Therefore local minimum equal to 0 and local maximum equal to 625. So now we discuss about the application and optimization exercise 7.8. So now maximum and minimum. You see here the function is maximum. So maximum means second derivative less than 0. So second derivative less than 0 means it is a maximum. And the second derivative greater than 0 means its value is answer is positive. It is a greater than 0. It is a minimum. Therefore at x equal to b, dy by dx equal to 0. The curve is minimum. So the curve is minimum means d square y by dx square greater than 0. So here everything it depends on the dy by dx. So maximum means d square y by dx square less than 0. Minimum means d square y by dx square greater than 0. So therefore at x equal to a. So at x equal to a means dy by dx equal to 0. The curve is maximum. The curve is maximum means d square y by dx square less than 0. This is the curve is maximum. So steps to find maximum or minimum. So now we find out the maximum and minimum. First we can find out the dy by dx. Dy by dx means first derivative. Next we take the second derivative. So y equal to f of x means this is a function. From this we find out the first derivative dy by dx. Second derivative d square y by dx square. So third step we take dy by dx equal to 0. So e equal to 0 means so next value of x. So we substitute from this step we find out the x values. That x values we substitute in the second derivative. So the second derivative answer is positive. So we represented the greater than 0. It is a minimum. So the second derivative value answer is minus. So it is represented by less than 0. So it is a maximum. Therefore value of y equal to f of x gives maximum and minimum values. Now we discuss about the exercise 7.8. So first question, find two positive numbers whose sum is 12 and their product is maximum. You see, that means they ask about the two positive numbers. We add the two numbers, we get the answer 12. So they give that sum is 12 and their product is maximum. So now I consider the two numbers x and y are the two numbers. So they give about the sum is 12. So sum is 12 means sum of two numbers equal to 12. So therefore x plus y equal to 12. So x plus y equal to 12 means y equal to 12 minus x. Let p denote their product. So next p is the product. So p equal to xy. So they tell about the product is maximum. So p equal to xy. So p equal to x into y answer is 12 minus x. That means I multiply x into I multiply these two factors. So 12x minus x square. Therefore p equal to 12x minus x square differentiate with respect to x. So tp by dx. tp by dx equal to I differentiate the 12 into differentiation of x is 1. So 12 minus differentiation of x square is 2x. So 12 minus 2x. So differentiate with respect to, from this I write it again, second time again differentiate with respect to x. So I differentiate this function dp by dx. So I get d square b by dx square equal to, both the side differentiate with respect to x. So d square p by dx square equal to, I differentiate the 12, it is 0, minus into differentiation of 2x minus 2x is minus 2. Therefore d square p by dx square equal to minus 2. So therefore dp by dx equal to 0 means 12 minus 2x equal to 0. So 2x equal to 12. So that means I write it x equal to 6. Therefore x equal to 6 in d square p by dx square. So minus 2. So d square p by dx square equal to minus 2 means it is a less than 0. Minus answer we represented by less than 0. It is a maximum. Next x equal to 6 in y equal to 12 minus x, because x point find out, we need the y point. So y equal to 12 minus x. Therefore y equal to 12 minus x value is 6. 12 minus 6 is y equal to 6. The point is 6 comma 6. Therefore numbers are x equal to 6 and y equal to 6. You see, they ask about the numbers. So first I write they give the only sum hints. First hint is the sum is, that means we find out, they ask about the two numbers, that number we adding, that means the sum is 12. This is a given conditions. And they ask about, they give another given conditions, product is maximum. So therefore let x and y be two numbers. Therefore x and y be two numbers means sum of two numbers. So sum of two numbers equal to 12. So x plus y equal to 12. X plus y equal to 12 means 12 equal to y equal to 12 minus x. So next p equal to xy, and substitute that y value here. So I get the p equations. And next first derivative, I find the first derivative tp by dx, and the second derivative after that tp by dx equal to 0 means I find out the point x equal to 6 and substitute in the d square p by dx square. This is a minus 2 less than 0. So it is a maximum. Therefore x equal to 6 in y equal to 12 minus x. So I substitute here. So therefore y equal to 6. So the point is 6 comma 6. Therefore the numbers are x equal to 6 and y equal to 6. These are two numbers. We add these two numbers, we get the answer 12. So it is a given condition satisfied. Next second problem, find two positive numbers whose product is 20 and their sum is minimum. So you see, so they ask about the two positive numbers, that means x and y be two positive numbers, and next they give the product. So product is 20 and their sum is minimum. So first I consider that two numbers x and y be two positive numbers. So product of two numbers equal to 20. So product of two, I take the two numbers is x and y. So product means xy equal to 20. So next y equal to 20 by x. So let s denote their sum. So that sum is, I take the s equal to x plus y. So s equal to x plus y, instead of, that means now y equal to 20 by x. So I substitute in this equation x plus 20 by x, differentiate with respect to x. So ds by dx equal to differentiation of x is 1 and differentiation of 1 by x is minus 1 by x square, minus 20 by x square. So which implies again second time differentiate with respect to x. So d square s by dx square equal to So differentiation of a second time is minus differentiation of 1 is 0 minus 20 into differentiation of 1 by x square is, that means minus 20 into minus 2 by x cube. This is the differentiation of minus 20 by x square. Minus 20 is constant, I write it. Differentiation of x square 1 by x square is, you put the power, that means minus 2 by, we increase the power in the denominator, x power 2 plus 1 3. So this is the differentiation of 1 by x square. So minus into minus plus, therefore d square s by dx square equal to minus into minus plus 40 by x cube. So in the next step now, ds by dx equal to 0. So ds by dx equal to 0 means 1 minus 20 by x square equal to 0. So this is minus 20 by x square in the right hand side. So 1 equal to 20 by x square. So just doing the cross multiplication, x square equal to 20. So x equal to square root of 20, 4 5s are 20. So plus or minus 2 root 5. This is the x equal to plus or minus 2 root 5. So x equal to, now I consider the positive, x equal to 2 root 5. So therefore I substitute in the second derivative. That means d square s by dx square, I substitute x equal to 2 root 5 here in this equation. So I got the answer positive. So greater than 0. Greater than 0 means minimum. Therefore s is minimum. Next x equal to 2 root 5. I substitute in the, so x equal to 2 root 5. So y equal to 20 by 2 root 5. So in the next step, multiply and divide by root 5. So 20 by 2 root 5, root 5 by root 5. So root 5 can, that means we multiply the root 5, we get the 1 5. So 2 5s are, that means 2 5s are 10. So 20 into root 5. So now the 10 divide the 20. So 2. That means the 0 0 cancelled. Therefore 2 root 5. This is the y equal to 2 root 5. Therefore the positive numbers are 2 root 5 comma 2 root 5. This is the two numbers. We add this, we multiply these two numbers, we get the answer. So we multiply these two numbers, we get the answer, that means 20. 2 root 5 into 2 root 5, 2 2s are 4, 4 into 5, 20. So this is the given condition is satisfied. So third problem, find the smallest possible value. Find the smallest possible value of x square plus y square x square plus y square given that x plus y equal to 10. So they ask about the find the smallest possible value of x square plus y square. So they given the equation x plus y equal to 10. So y equal to 10 minus x. So now I take this function as x square plus y square equal to f of x. F of x equal to x square plus y square. So f of x equal to x square. Now I substitute y equal to 10 minus x. So 10 minus x whole square. So differentiate with respect to x. So differentiate with respect to x, and now I take the differentiation. So f dash of x equal to, that means the differentiation of x square is 2x plus the differentiation of 10 minus x whole square is 2 into 10 minus x, and the differentiation of a base 10 minus x is minus 1. So which implies f dash of x equal to 2x minus 2 into 10 minus x. Therefore f dash of x equal to 2x minus, I multiply the minus 2 in the factor, so minus 20 plus 2x. Therefore f dash of x equal to, I add the this value is x terms, so 4x minus 20. Again I differentiate with respect to x. F double dash of x equal to, I differentiate the 4x, so 4 into differentiation of x is 1. So therefore f double dash of x equal to 4. So now I take f dash of x equal to 0. F dash of x equal to 0 means 4x minus 20 equal to 0. So 4x minus 20 equal to 0 means 4x equal to, this minus 20 I write in the right hand side. So 4x equal to 20. So x equal to 20 by 4. 20 by 4 means 5. X equal to 5. So I substitute x equal to 5. So x equal to 5 means, that means in the f double dash. So f double dash of 5 equal to 4. So the answer is positive, it is greater than 0. Therefore it is a minimum. Next, so when x equal to 5, the function is minimum, f is minimum. Next I substitute. So I find out the minimum value. Therefore x equal to 5, f of 5 equal to 5 square plus here I substitute f of 5 equal to 5 square plus 10 minus 5 whole square. So 5 square is 25. 25 plus 10 minus 5 is 5 square. So 25 plus 25, 50. So f of 5 equal to 50. Therefore 25, 25, 50. Therefore the smallest possible value is 50. Next we discuss about the fourth problem. A garden is to be laid out in a rectangular area and protected by wire fence. What is the largest possible area of the fenced garden with the 40 meters of wire? So you see that this is a rectangle garden. So a garden to be laid out in a rectangular area. This is a rectangular area of the garden and protected by a wire fence. All the border are covered by the wire fence. And next, what is the largest possible area of the fenced garden with the 40 meter of wire? So they ask about the largest possible area with the 40 meters of wire. So you see, let x and y be the width and length. Here I take the x is the width and y is the length. So this is a y. Y means this is a horizontal length, horizontal line. This is a y. So it is the y is the x I take the width, y I take the length. So y represent the length and x represent the width. Therefore, given that the total length of the fencing is here, they ask about the here they give the total length is 40 meter. Therefore, given that the total length of the fence is 40 meter. So now, so total length I take, that means 2x plus x and y plus y. So I represent here x plus x plus y equal to 40. This is total length x, y, x, y. So 2 times of x, 2 times of y. So x plus y equal to 40. This is the total length of the garden. So next 2x plus 2y equal to 40 means I take the 2 from the term. So 2 into x plus y equal to 40. That 2 that means that 2 divide the 40. So 40 by 2 is 20. X plus y equal to 20. So divided by 2 we get the answer x plus y equal to 20. So therefore y equal to 20 minus x. So we know the area of the rectangle. Area of the rectangle is xy. Therefore a of x equal to x into y value is 20 minus x. Therefore just multiply this two factor, 20x minus x square. So differentiate with respect to x. A dash of x equal to 20 into differentiation of x is 1. So 20 minus differentiation of x square is 2x. So 20 minus 2x. So next a double dash of x. Differentiation of 20 is 0. Differentiation of minus 2x is minus 2. Therefore a dash of x equal to 0 means it is a 20 minus 2x equal to 0. So I write it, that means I write it the 2x equal to this minus 2x I write in the right hand side. So 20 equal to 2x, I reverse the equation, 2x equal to 20. Therefore x equal to 20 by 2, x equal to 10. So x equal to 10. When x equal to 10 in a double dash of x equal to minus 2. I substitute x equal to 10 in the a double dash of 10 equal to minus 2. So minus value I represented the less than 0. So less than 0. Therefore x less than 0 means it is still the area is maximum. So therefore when x equal to 10, area is maximum. Next x equal to, I substitute this x equal to 10 in the function y equal to 20 minus 10. So y equal to 10. Therefore x value is equal to, that means length is the breadth is 10 and length is y equal to 10. So the largest possible area is xy. We know the area of the rectangle xy. So I substitute xy values 10 into 10. So 100 meters square. This is the possible largest area equal to 100 meters square. We complete the class.